NENOMATICA, where mathematics meets YouTube excellence. Exponential equations. Welcome! In this example, we solve the exponential equation 3 raised to the power of x squared minus 2x plus 2 equals 5 raised to the power of x, with the condition that x is not equal to 0. To solve this equation, we'll first raise both sides to the power of 1 over x. This will help us simplify the expression. Next, we simplify the exponents using the property that a to the power of b, all raised to the power of c, equals a to the power of b times c. Since x over x equals 1, we can further simplify the right side to just 5. To eliminate the exponent, we take the logarithm with base 3 of both sides. Using the logarithm power rule, the logarithm of a to the power of b equals b times the logarithm of a, so we bring down the exponent from the power. Since the logarithm of a number with its own base equals 1, log base 3 of 3 equals 1. We can further simplify by removing the multiplication by 1. Now, let's multiply both sides by x to eliminate the fraction. Let's rearrange this equation into standard form for a quadratic equation, with all terms on one side. We can combine like terms by factoring out x from the x log base 3 of 5 and negative 2x terms. Now, we have a quadratic equation. To solve for x, we'll use the quadratic formula, which states that for an equation of the form ax squared plus bx plus c equals 0, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. We substitute these values into the quadratic formula. Here, at equals 1, b equals negative log base 3 of 5 minus 2, and c equals 2. We can simplify negative of negative log base 3 of 5 plus 2 to just log base 3 of 5 plus 2. And since it equals 1, we can simplify the denominator to just 2. Therefore, the solutions to our original equation are x equals log base 3 of 5 plus 2 plus or minus the square root of log base 3 of 5 plus 2 quantity squared minus 8, all divided by 2. Note that we also need to check that our solution satisfies x is greater than 0, since we divided by x earlier. This completes our solution of the exponential equation. We applied several key properties, the power rule for exponents, logarithm properties, and finally the quadratic formula to find our answer. Let's start with our example problem. We need to solve the equation 3 to the power of x times 8 to the power of x over x plus 1 equals 36. Our first step is to express all terms with the same base. Let's start by remembering that 8 equals 2 cubed, so we can rewrite 8 to the power of x over x plus 1 as 2 to the power of 3 times x over x plus 1. Also, 36 can be written as 3 squared times 2 squared. Next, we'll divide both sides by 3 squared times 2 squared to isolate our variable terms. When dividing powers with the same base, we subtract the exponents. So 3 to the power of x divided by 3 squared becomes 3 to the power of x minus 2. Similarly, 2 to the power of 3x over x plus 1 divided by 2 squared becomes 2 to the power of 3x over x plus 1 minus 2. Next, we'll manipulate the exponents to rewrite this as a single power. First, let's simplify the exponent of 2. 2 to the power of 3x over x plus 1 minus 2 can be rewritten as 2 to the power of 3x minus 2 times x plus 1 over x plus 1, which simplifies to 2 to the power of x minus 2 over x plus 1. This allows us to rewrite our equation as 3 times 2 to the power of 1 over x plus 1, all raised to the power of x minus 2. Since we have a power equal to 1, we'll take the logarithm of both sides to bring down the exponent. By the logarithm power rule, the logarithm of a number raised to a power equals the power times the logarithm of the number. So we get x minus 2 times the logarithm of 3 times 2 to the power of 1 over x plus 1 equals the logarithm of 1, which is 0. By the zero product property, if a product equals 0, then at least one of the factors must be 0. So either x minus 2 equals 0, which gives us x equals 2, or the logarithm of 3 times 2 to the power of 1 over x plus 1 equals 0. For the second case, we know that if the logarithm of a number equals 0, then that number equals 1. So we get 3 times 2 to the power of 1 over x plus 1 equals 10 to the power of 0, which is 1. Now, we'll isolate the power term by dividing both sides by 3. We can rewrite 1/3 as 3 to the power of -1. To solve for x, we'll take the logarithm base 3 of both sides. Using the logarithm power rule again, we get 1 over x plus 1 times the logarithm base 3 of 2 equals -1 times the logarithm base 3 of 3. Since the logarithm base 3 of 3 equals 1, we can multiply both sides by x plus 1 to get x plus 1 times -1 equals the logarithm base 3 of 2. Simplifying, we get -x minus 1 equals the logarithm base 3 of 2. Solving for x, we get x equals -1 minus the logarithm base 3 of 2. Therefore, our final solution set consists of two values, x equals 2 from our first case, and x equals -1 minus the logarithm base 3 of 2 from our second case. Welcome to our lesson on solving exponential equations. Today, we'll solve the equation x raised to the cube root of x squared equals the square root of x raised to the power of x. To solve this equation, we'll first apply logarithm to both sides. This is a common technique for solving equations where variables appear in exponents. Using the logarithm allows us to bring down the exponents and make the equation easier to manipulate. Next, we'll apply the logarithm power rule, which states that the logarithm of a number raised to a power equals the power times the logarithm of the number. Mathematically, this is written as log of a raised to be equals b times log of a. Using this rule on both sides of our equation, we get cube root of x squared times log x equals x times log of square root of x. Now, let's express the roots as fractional exponents to simplify our work. The cube root of x squared can be written as x to the power of 2/3, and the square root of x can be written as x to the power of 1/2. We can apply the logarithm power rule again to the right side of the equation. This gives us x to the power of 2/3 times log x equals 1/2 times x times log x. To solve for x, let's bring all the terms to the left side of the equation. We subtract 1/2 times x times log x from both sides, giving us x to the power of 2/3 times log x minus x over 2 times log x equals 0. Notice that log x is a common factor in both terms on the left side. Let's factor it out. The expression becomes the quantity x to the power of 2/3 minus x over 2 times log x equals 0. When we have a product equal to 0, either one or both of the factors must be 0. So we have two cases to consider. Case 1, log x equals 0, which implies x equals 1. Case 2x to the power of 2/3 minus x over 2 equals 0. Solving this equation. For the second case, let's solve the equation x to the power of 2/3 equals x over 2. We can manipulate this to find the value of x. First, multiply both sides by x to the power of minus 2/3 to get 1 equals x over 2 times x to the power of minus 2/3, which simplifies to 1 equals x to the power of 1/3 over 2. Multiplying both sides by 2, we get 2 equals x to the power of 1/3. Cubing both sides, we find that x equals 8. Therefore, we have found that this exponential equation has two solutions, x equals 1 and x equals 8. The solution set can be written as D equals the set containing 1 and 8. To summarize, we solve this exponential equation by taking the logarithm of both sides, applying the logarithm power rule, expressing roots as fractional exponents, factoring out common terms, and then solving the resulting cases. The techniques we used can be applied to solve many types of exponential equations. Welcome to our lesson on solving exponential equations. We're going to walk through this example step by step. Let's solve this exponential equation. To simplify our work, we'll first multiply both sides by 2 minus square root of 3. After multiplying, the right side simplifies because 2 minus square root of 3 cancels out with the denominator. Now, let's focus on the left side. We can rewrite the first term. Notice that x squared minus 2x plus 1 can be rewritten as 1 plus x squared minus 2x. Now, we'll use an important property. 2 plus square root of 3 and 2 minus square root of 3 are related in a special way. The product of 2 plus square root of 3 and 2 minus square root of 3 equals 1. Let's make this equation easier to work with by letting t equal 2 plus square root of 3 raised to the power of x squared minus 2x. Now our equation simplifies to t plus 1 over t equals 100 and 1 over 10. We have two possible values for t, either t equals 1/10 or t equals 10. Let's focus on the second case, where t equals 10. We take logarithm of both sides to get log of 2 plus square root of 3 raised to the power of x squared minus 2x equals log of 10. Using the property of logarithms, we can bring the exponent down x squared minus 2x times log of 2 plus square root of 3 equals log 10. Now, we solve for x squared minus 2x by dividing both sides by log of 2 plus square root of 3. This can be written more compactly as x squared minus 2x equals log base 2 plus square root of 3 of 10. Now, we form a quadratic equation by subtracting log base 2 plus square root of 3 of 10 from both sides. We can solve this quadratic equation using the quadratic formula. The solutions are x equals 1 plus square root of 1 plus log base 2 plus square root of 3 of 10, or x equals 1 minus square root of 1 plus log base 2 plus square root of 3 of 10. And these are our solutions to the exponential equation. This problem demonstrates important techniques, including substitution, logarithm properties, and solving quadratic equations. Let's look at our example problem. We need to solve the exponential equation. 5 raised to the power of 2x minus 1 equals 7 raised to the power of 3 minus x. To solve this exponential equation, we need to get rid of the exponents. One way is to apply the logarithm to both sides of the equation. So let's take the logarithm with base 5 of both sides. This gives us log base 5 of 5 raised to the power of 2x minus 1 equals log base 5 of 7 raised to the power of 3 minus x. Now, we can use the logarithm property that states the logarithm of a power equals the exponent times the logarithm of the base. So, log base 5 of 5 raised to the power of 2x minus 1 equals 2x minus 1 times log base 5 of 5. Similarly, log base 5 of 7 raised to the power of 3 minus x equals 3 minus x times log base 5 of 7. We know that the logarithm of a number with the same base equals 1. So log base 5 of 5 equals 1. This simplifies our left side to just 2x minus 1. On the right side, we can distribute the logarithm term. This gives us 3 times log base 5 of 7 minus x times log base 5 of 7. To solve for x, let's rearrange the equation to group all terms with x on the left side and all constants on the right. We'll add x times log base 5 of 7 to both sides and add 1 to both sides. This gives us 2x plus x times log base 5 of 7 equals 1 plus 3 times log base 5 of 7. Now, we can factor out x from the left side of the equation. This gives us x times the quantity 2 plus log base 5 of 7 equals 1 plus 3 times log base 5 of 7. Finally, we can solve for x by dividing both sides by the quantity 2 plus log base 5 of 7. This gives us our final answer. X equals the fraction with numerator 1 plus 3 times log base 5 of 7 and denominator 2 plus log base 5 of 7. And that's our solution. To verify it, you could substitute this value of x back into the original equation and check that both sides are equal. Let's review what we've learned. To solve exponential equations with different bases, we can use logarithms to transform the equation into a linear form. We applied the logarithm properties, simplified, and then solve for our variable. This approach can be used for many exponential equations where the bases are different. We need to solve the following exponential equation. The square root of 3/5 multiplied by 3/5 raised to the power of x minus 1 equals the fourth root of 5 raised to the power of 3x minus 4 divided by the square root of 5. To solve this equation, we'll use logarithms. Specifically, we'll apply logarithm base 5 to both sides of the equation. The first step is to take the logarithm base 5 of both sides of the equation. Next, we'll use the logarithm property that states log of a product equals the sum of logarithms. So, log base 5 of the square root of 3/5 times 3/5 raised to x minus 1 equals log base 5 of the square root of 3/5 plus log base 5 of 3/5 raised to x minus 1. Similarly, on the right side, we apply the property that log of a quotient equals the difference of logarithms. So we get log base 5 of the fourth root of 5 raised to 3x minus 4 minus log base 5 of the square root of 5. Now we'll apply more logarithm properties. The logarithm of a number raised to a power equals the power times the logarithm of the number. So log base 5 of the square root of 3/5 equals 1/2 times log base 5 of 3/5. and log base 5 of 3/5 raised to the power of x minus 1 equals x minus 1 times log base 5 of 3/5. On the right side, log base 5 of the fourth root of 5 raised to 3x minus 4 equals 3x minus 4 divided by 4 times log base 5 of 5, which equals 3x minus 4 divided by 4, because log base 5 of 5 equals 1. Similarly, log base 5 of the square root of 5 equals 1/2 times log base 5 of 5, which equals 1/2. In this step, we'll further simplify the logarithm expressions. We know that log base 5 of 3/5 can be written as log base 5 of 3 minus log base 5 of 5. Also, we know that log base 5 of 5 equals 1, so we'll substitute this value. The left side becomes 1/2 times log base 5 of 3 minus log base 5 of 5, plus x minus 1 times log base 5 of 3 minus log base 5 of 5. The right side becomes 3x minus 4 divided by 4 times log base 5 of 5 minus 1/2 times log base 5 of 5, which simplifies to 3x minus 4 divided by 4 minus 1/2. Now, we'll expand the expressions on the left side. This gives us 1/2 times log base 5 of 3 minus 1/2 plus x times log base 5 of 3 minus x minus log base 5 of 3 plus 1. We can rearrange this to 1/2 times log base 5 of 3 minus 1/2 plus x times log base 5 of 3 minus x minus log base 5 of 3 plus 1. The right side remains as 3x divided by 4 minus 1 minus 1/2, which equals 3x divided by 4 minus 3/2. Let's simplify the left side further by combining similar terms. We can combine 1/2 log base 5 of 3 and negative log base 5 of 3 to get negative 1/2 log base 5 of 3. Also, we can combine negative 1/2 and positive 1 to get positive 1/2. So the left side becomes negative 1/2 times log base 5 of 3 plus 1/2 plus x times log base 5 of 3 minus x, while the right side is 3x divided by 4 minus 3/2. Now, we'll move all terms containing x to the left side, and all other terms to the right side. So x times log base 5 of 3 minus x minus 3x divided by 4 equals negative 3/2 plus 1/2 times log base 5 of 3 minus 1/2. This simplifies to x times log base 5 of 3 minus x minus 3x divided by 4 equals negative 3/2 plus 1/2 times log base 5 of 3 minus 1/2, which further simplifies to x times log base 5 of 3 minus x minus 3x divided by 4 equals negative 2 plus 1/2 times log base 5 of 3. We can factor out x from the left side. This gives us x times log base 5 of 3 minus 1 minus 3/4, which equals x times log base 5 of 3 minus 7/4 equals negative 2 plus 1/2 times log base 5 of 3. Finally, we solve for x by dividing both sides by the coefficient of x. So x equals negative 2 plus 1/2 times log base 5 of 3 divided by log base 5 of 3 minus 7/4. This gives us our final answer. And there we have it. We've successfully solved this exponential equation using logarithm properties. Let's summarize the key steps we followed. First, we applied logarithm base 5 to both sides of the equation. Then, we used logarithm properties to expand and simplify both sides. We rearranged terms to isolate those containing the variable x. Finally, we solved for x to get our answer. This approach can be applied to many types of exponential equations. Remember that logarithms are powerful tools when dealing with exponential terms. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.